Now, as I mentioned, templates are cascading. So you can actually have multiple different settings that filter down to a single device from different templates. And templates are applied at the global level. So there's an everything template. It's basically the global default. This is typically where you would want to set things like a contact of last resort. So you can always make sure everything that gets put under monitoring gets an alarm for it. You could also set really general parameters for thresholds like latency thresholds or error thresholds that you kind of want to apply to everything. The next level down is type specific templates, and these are allowed to apply anything that's type specific to the device. In this example, like a Cisco router template might have settings for, looking at my Cisco configuration. It might have settings for looking at for hardware problems that are specific to that particular device type. As I mentioned, subtypes typically are going to be used for specific applications running on that device. And then you've also got the ability to apply templates at the site level and at the category level, as well as on the device itself. So if I apply templates all the way on the device itself, those will override any templates coming from higher levels. So the most specific template always overrides the more general templates. This lets us build a hierarchy of how our templates are constructed to kind of simplify and minimize the amount of templates that we need. And so to illustrate how that works, on this device, if I've got a latency setting at the default level, which is the global level, and then I also have a different latency setting at the site level, and then a different one that applies to the device itself, only the setting from the device actually passes down. But if I'm setting a value like at the type level, for example, and it's not overridden by any of those other templates, it'll pass straight down onto the device unedited. So to kind of define how templates are inherited, there's three major things that inherit from templates. Host alert contacts are used when a host goes down, who do I notify? And host alert contacts are defined with something called an escalation level. So that basically tells us whether or not this person gets alerted as soon as the device goes down, or if there's some later tier of escalation after the device has been down for a length that you specify. So in this case, if I set a contact or an action group of help desk at the global default level, and then I set another one at the site level, but with a different escalation threshold, the site level in this case is the one that gets inherited onto the device. But if I set a completely different contact group on the type level, that's going to pass down to the device. So when I look at the device, I'm going to have the WinAdmin contact that I inherited from the Windows Server level. I'm going to have the help desk, but it's going to be inherited from the site level, and I can tell that by the escalation threshold that's on it. And I'll show you how to look at settings in OmniCenter and tell whether or not they came from a template and what template they came from. With service checks, every service check has a unique description, and that description is what defines whether or not a service check gets overridden in a more specific template. So if I have two service checks and they're both named web, the one at the global level and the one at the site level, again, the site level will override the global level, and whatever settings I have associated with that web check at the site level will replace the settings in the global default template. If I set a different description, even if it's checking the same web page, if it's got the description is different, it'll pass down onto the device and you'll get multiple checks on the device. So that's something to be aware of when you're setting up service checks. Thresholds are the third major thing that passes down. And with thresholds, they're unique by statistic. So if I'm looking at something like latency, for example, again, the more specific one is simply going to override. If I'm looking at something that's a little bit more dynamic, like disks, for example, if I set a disk threshold at the default level, it's going to apply to all of the disks on that device. But if I put in a disk threshold at the type level that has a substring, so it's a more specific filter, that's going to change the settings for anything that matches that substring. So in thresholds, you have this concept of substrings. When you're looking at things, you can have multiple instances on a device. You can filter them out by those substrings, and that'll control exactly what settings end up passed through to the device.